Students, can you hear me? Okay. Today we will be seeing. Yesterday we saw in Queen's problem how to place the queens in the 4x4 chessboard, right? So, how to place the four queens on a 4x4 chessboard using backtracking technique, right? So, when you start with particular problem with some path and you go through some path and you reach at dead end, and you are not able to uh, arrive at any solution, then you can. One second, students. I will just increase my volume. One second. I think there is no problem in hearing me now. You're able to hear? Please respond, one of you. Then I can proceed.
Yes.
Okay, fine. So, so the last class, how to draw the state space tree for the n-queens problem we saw. So today what I'm going to teach is job assignment problem using branch and bound technique. Okay, so branch and bound technique, how it is. One second. So already you know that how to attack the job assignment problem, you know, right? So, but the only thing is we have done job assignment problem using exhaustive search, like going through all the possible solution and then coming out with a probable solution. So like that we have done. So always it is in the process. One second. So now how to, no, we are going to assign the jobs to the persons. So if I'm assigning job 1 to person 1, the same job cannot be assigned to person 2. So that is how we've been doing. So here, yesterday we saw about backtracking, right? Backtracking, how to solve the n-queens problem. Today we are going to talk about the branch and bound algorithm. I mean the design technique, okay? So this fifth module I have started now. Sum of subset we have finished using backtracking. n-queens I have done using backtracking. Now I'm doing branch and bound method. Okay. This is going. One second. Yeah. So we have come to job assignment problem, how to assign and how to draw the state space tree. All that I'm going to teach you. Not able to go to the next page. So again, branch and bound strategy, if you see, it is a one kind of optimization problem. Okay. So we can say branch and bound technique is an improvement of backtracking technique. And for each node, okay, so when I talk about each node, it is going to give you the partial solution. Okay, so of a state space tree, it computes a bound on the value of the objective function. So for all the descendants of the node. So how, now we'll come back to the theory part. after we understand what is now what we do is certain nodes are classified as non-promising nodes. Okay, so if a nodes bound is not better than the best solution seen so far, so we need to what we do, we to start eliminating certain nodes as non-promising nodes. So this terminology, again I am repeating it or reiterating it. Some things are going to be told as I mean, we are categorizing some nodes as non-promising nodes. Okay, so basically how it is. And when we construct a state space tree, how to go about in construction of state. So here also in branch and bound technique also, we will construct a state space tree to attack the problem, right? So we'll do that. That is okay. Now, but how to categorize where should we stop? I mean, where is that non-promising nodes what we are talking about? That part has to be understood clearly, right? So we'll just go one by one how that state space tree is drawn for job assignment problem. Okay, so what is this assignment problem? We have been reiterating it. Job assignment problem is to assign n people to n jobs so that the total cost of the assignment is as small as possible. So it is a kind of minimization problem. So knapsack problem is a maximization problem. So there are many optimization problems what we are talking about throughout the syllabus. So you should also understand few things. In knapsack problem, we want to maximize the profit. Okay, we are filling the knapsack or a bag with the most valued set of items. Okay, whereas your job assignment problem is a kind of minimization problem, in the sense the total cost incurred should be as small as possible. Okay, so how am I going to assign n people with the n job? Okay, so the same job cannot be assigned to the different people. So now we'll take an example and then let us understand how this job assignment problem is going to work. Okay, so how it is going to work, we will see. Okay, now the person A, person B, person C. So here you can see here, okay, an instance of the assignment problem is specified by n by n cost matrix. So that cost matrix, we are calling it as C. Okay, so person A is assigned this job, person B is assigned this person. Now, these are the jobs which are taken. So now there are 4 jobs, there are 4 persons. Now I'm going to assign, we need to assign n people, that is 4 persons, 4 jobs, such that the total cost of the assignment is as small as possible. So that is what is required here, right? So now, see, now you can see by looking at this allotment, if we are going to pick up in each row which is minimized. Okay, so a person A is able to complete job 2 with the total cost of 2. Okay, so that is now minimize. We wanted to minimize the cost incurred. That is what I said. So what we will do is we will have some bound value here. Okay, in the branch and bound, as the name, as the algorithm design technique indicate, branch and bound. Okay, so what could be the value? What could be the value which can be no we how we can go about? Okay, what will be the value? So select one element in each row of the cost matrix such that no 2 selected elements are in the same column and their sum is minimized. Okay, so if I'm going to select person A with I'm assigning a person A with the job 2, person B also cannot be assigned job 2. Okay, so they have to be assigned some other job. So that is also there, but when I talk about the cost should be minimized. So the cost should be minimal. So that is all the problem about. So let us see how to solve this problem. Okay, Fine. Now the cost of any solution, including the optimal one. So now we will fix one lower bound for this problem. Please understand. I'm going to fix one lower bound. What is this lower bound? Let us understand. So the cost of this solution, including the optimal one, cannot be smaller than the sum of the smallest element in each of the matrix rows. So what is that matrix I'm talking about? The cost matrix, what I'm talking about. Let us understand this. So in each row, students, you are going to take the minimum one. So look at the first row, which is a minimal one. Can anyone tell? Which is a minimal one? In the first row, what is the minimum value you have to take? Anybody? Just to see the assignment and tell me in the first row, which is minimal value. Out of 9, 2, 7, 8, which is the minimal value?
2.
2. Okay. In second row, what is the minimal value? Quickly you tell. 6437. What is the minimal
3.
value? Huh?
3.
3. Okay. So in the third row, which is a minimal value? 5818, which is a minimal
1.
value? 1. And in the fourth row, which is a minimal value?
4.
7694. Okay. So if I'm going to pick up the minimal value in each of the rows and I'm going to add the total cost. So that is the lower bound I'm going to keep it for this job assignment problem. So I'm trying to assign jobs to different persons such that the cost of the assignment is as small as possible. So from the first row, which is having the minimum cost, right? So that I'm going to pick up. And this is basically a cost matrix, n by n cost matrix. The row indicates the persons and the column indicates the job which the persons are going to be assigned. And what are the values inside? The values are nothing but what would be the cost incurred when this job is assigned to this person. So what I'm trying to do in this thing is I'm going to set up my lower bound value. So how can I set up the lower bound value? By picking up the smallest value, by picking up the smallest value among each row. Okay. So I have picked the first row, the smallest one, 2. Cost incurred is 2. And the second row, 3. As the student was telling, like the third row it is 1 and the fourth row 4. Okay. So now let us see what is the lower bound I get. Let us add everything. That is 2 plus 3 5, 5 plus 1 6, 6 plus 4 10. I get the value 10, right? So that is my lower bound value. Okay. Okay, so any solution to the, now I have given you a problem to solve, and this solution for the problem. So any solution to the given instance will have the total cost at least 2 plus 3 plus 1 plus 4, which I have picked from each of the rows. 2 plus 3 plus 1 plus 4, 10. So we have now my solution may be, it may not be exactly 10, but it may be around this 10. Okay. So now the cost of any solution, including the optimal one. So I'm going to arrive at the optimal solution, right? So it cannot be smaller than the sum of the elements. So now we have picked up the smaller element. I have added the cost and I have got 10. Okay. So my solution will be somewhere around this. So that is the reason why I'm choosing the lower bound for this problem. Okay. So the lower bound, let me repeat again, the lower bound is nothing but, okay, let me repeat this. The lower bound is nothing but the cost of any solution, including optimal, so cannot be smaller than the sum of the smallest element in each of the matrix rows. So I'm picking the smaller element in each of the rows and I'm adding all the cost. So I get the total cost as 10. Okay. So what is this 2? We are choosing the node with the smallest value. Okay. So and then we will see how to go about. Now I have got the lower bound for this problem. Okay. Now let us start drawing the state space tree and understand what would be the value. Okay. Okay. So what I will do, I will start drawing the state space tree, keeping in mind. So let us start like lower bound value is 10. Okay. So I have made one lower bound value looking at this. Okay, so now you're able to visualize this. So level 0 will have the lower bound value, that is a start value. Next, what I should do? Okay, next what I should do? Lower bound value is 10. Already it is there. Now in level 1, what we are going to do? So that we have to understand. Okay, so 1 second, students. Yeah. Now what I will do? If I'm going to assign, now I will have the 4 possible values. No, that is, if I'm going to assign the first person with the first job, and first person with the first job, and second person with the lower one, and third person with 1, and fourth person with 4, what would be the value? So it will be the combination I'm going to check. Okay, so let the state space tree I've started drawing for the job assignment problem using branch and bound method. So my start or level 0 will have start and lower bound value. Lower bound value is nothing but 2 plus 3 plus 1 plus 4, that is going to be 10. Okay, so let us go to the level 1. In level 1, what are the possibilities? Let us understand. So if I'm going to assign the first, so C11 plus C23 plus C33 plus C44. So that is what we are doing. So C11 is the first person is assigned first job. So what is the cost incurred? 9. So 9 plus 3. Second person, third job. Third person, second person, third job. Third person, third job. And fourth person, fourth job. So 9 plus 3 plus 1, I'll get 7. 17. Add it. Okay. Now, if I'm going to assign, so what are the other possibilities? Let us understand. Okay. So if I'm going to lower bound, the other value could be, if I'm going to assign the first person the second job. Okay. If I'm going to assign the first person with the second job, what would be the value? 2. Right. So it will be 2 plus 3 plus 1 plus 4. It is 10. Now, if I'm going to assign the first person with the third job, what is the value? So it is 7 plus 4 plus so this could be the other possibility, no? So we have to look for now 7 plus 4 plus 5 plus 4. So that could be the possibility. That is, let us understand the third one. First person, I'm assigning the third job. Okay. And second person, I'm assigning the second job. Okay, second person I'm assigning the second job, and third person I'm assigning the first job, and fourth person I'm assigning the fourth job. See, understand students, the same job cannot be assigned to more than one person. So these are the possibilities I get. Okay, so now I have got 4 possibility. In that, look at the value 17, 10, 20 and 18. So which is a smaller one? 17, 10, 20 and 18. So I got out of 17, 10, 20 and 18, the most promising is node 2. So this I'm just calling as 1, 2, 3, 4. The most promising of them is node 2 because it has got the smallest lower bound value. So among all this, I have to select this, right? 2 plus 3 plus 1 plus 4. So that will be the most promising node. So let us go to the level 3. Sorry, level 2. Okay, so I have got this. Now listen. So my start value, this is your level 0. This is your level 0. Just let me understand. Let me make you understand. So why it is okay. Now level 0 start, and the lower bound value I got as 10. That is picking up the smaller one. Now next level 1, I have got the node 2. That is a is equal to lower bound value got 10. Next I have to choose go to the next level. Okay, so going to the next level, what I should do, please understand here. Okay, so next level, what I will do, I will try getting the, see, basically I'm looking for a path. Okay, so which level what persons should be assigned. Okay, now let us understand what is this node 5. Node 5, what is it, that we have to understand. So what is a node 5 is, the first person is assigned the second job. Okay, first person is assigned the second job, second person is assigned the first job. So you have to add, please understand, first person is assigned the second job, what is the value? 2. Okay, let us have everything here so that it will be easy for you. 2 plus, then second person is assigned the first job, so 2 plus, what is the value? 6. 2 plus 6 plus, then we have third person is assigned third job, so 1. So 2 plus 6 plus 1 plus fourth person is assigned fourth job, so 2, 4. 2 plus 6 plus 1 plus 4, I get the lower bound value as 13. Okay. So now next we will go for the next node 6. What is that we are doing? Okay. So here what is happening here is, okay, now what is a possibility here? First person is assigned the second job. Okay. And then the second person is assigned the third job. Okay. Second person is assigned a third job, and third person is assigned the first job. Okay. So it will be 2 plus 3 plus 5 plus 4. So what is that? I get 14. And then what is the other possibility? We'll see. Now first person is assigned the second job, that is 2, right? So that is 2. One second, students. So 2 plus 7 plus 1 plus 7. So how are we getting? We'll understand. 2 plus 7 plus 1 plus 7. That is, first person is assigned the second job, and then second person is assigned the fourth job, and third person is assigned the third job, and fourth person is assigned the first job. So now among all this, which is going to be the feasible solution? Okay. So feasible solution, how we will get? So that 13, 14 and 17, they are all compared. Now I'm going to pick up the node 5, because that's going to be the feasible solution, because this is the minimum cost which is incurred. Out of 13, 14 and 17, 13 seems to be the smaller one. So I'm going to pick up that. So 13. So we are building the tree level 0, 1, 2, 3 like that. Okay, so we started with this. We started with this lower bound value, which we have got from picking the minimum value. Then we chosen the second node. Okay, so out of the many cost which is incurred, we have chosen the minimum value. Then we are going to pick up the fifth node, because the lower bound value is going to be 13 there. Next, next what we have to do, we have to assign the solution. Now again, we have to look for other solution. So what is that solution? We will see. Okay, so here if you see eighth, what is the eighth node talking about? The first person will be assigned the second job, that is 2. Okay, 2 plus second person will be assigned the first job, so 2 plus 6. And then third person will be assigned the third job. Okay, so here it is 1, and fourth person will be assigned 4. So 2 plus 6 plus 1 plus 4. So we know that the first person has to be assigned the second job. So that is already no, we have decided, right? So now we have to look for no decision making. So basically looking for all the possibilities, and then among all the feasible solution, again looking for the most optimal. So going through like that. Okay, one second. And here what we are doing, we are trying to assign, one second, yes, I just answer to your question. Just let me just finish, then we'll see how that path we are taking. Okay, so ninth solution, if you see the cost incurred here, if you see what is the value I'm getting, 2 plus 6 plus 1 plus 4. So we have assigned first job, sorry, first person the second job, second person the second first job, and third person is assigned the third job, and fourth person is assigned the fourth job. So 2 plus 6 plus 1, I get 13. So what is the other possibility we have? 2 plus 6 plus, see, if I am assigning the first person second job, Then for the second person, I have the probability of assigning either first or third or fourth. So you should also understand that way. And then when you sum this cost, I get it as 25. Now, if you look at 13 and 25, the solution will be 13 for this problem, which is more or less than the optimal solution. The first we had fixed some lower bound for this problem was 10. Now, the solution for this would be 13. Okay, so but this cost of 25 is going to be an inferior solution. So we will not take up this solution. So we are going to come up with this like this. That is, first person is assigned A, B, C, D are the persons. Okay, so first person is assigned the second job. Okay, so and then the second person is assigned the third job, and sorry, second person is assigned the first job, and third person is assigned third job, and fourth person is assigned the fourth job. So that would be the most optimal solution, right? So we will do one more problem, don't worry. If you feel that it is confusing or something. So the complete state space tree, how it was drawn is like this. So initially what we did for node 0, what we did was lower bound. Just we picked up small values from each of the rows. So we got the lower bound value as 10. Next, what we are doing, we are looking at all the possibility. Now in level 1, what are we doing? We are finding node 1, 2, 3, 4. No, among that 2 is the most promising node. So how we got this 2, right? So we are again branching out for looking all the possibilities, right? So we are so in this is the complete state space tree. In level 1 we had 4 nodes. Level 2, node level 0 or node 0 we have only one, which is nothing but the lower bound. Okay, whereas in level 1 we had 4 possibilities, and level 2 we had again these many possibilities. So how we are assigning jobs to each person is looking out all the possibilities and checking for which would be the most optimal one. So that is what is the idea here. That is what is the idea here, if you see. So each time I wanted to go for, I want to check which will be the most optimal solution. That is lower bound value. I may get 17, 10, 20 and 18. So in this 17, 10, 20 and 18, which is the most minimum? So it's a minimization problem. So the cost incurred will be which is less. So I'm going to choose 10 here, right? But when I'm constructing the state space tree, even in that n-queens problem, right? So possibility, there was no possibility of placing the queen itself. There we have reached a dead end and we backtracked it. But unlike that, now in branch and bound, we are branching out to all the possible solutions here. Out of that, the most optimal solution, we are taking it as the most promising node. Okay, so in this case, node 2, if you look at 17, 10, 20 and 18, 10 is going to be the most promising. Node 2 is going to be the most promising node. So we are choosing node 2 and then we try to branch out from there. Okay, so I'll be doing one more problem, taking if you get little confused about assigning. Okay, this is the complete state space tree. You can see, one second, students. Where is that? Some problem in scrolling also. This is okay. This is your complete state space tree, right? So complete space tree, state space tree is this. So we started with the lower bound. We got the lower bound as 10. Why? Because we have chosen the minimum value from each of the rows. The person A can be assigned some minimum cost. So like that, blindly we had chosen some minimum value. We took it as a lower bound for this problem. Okay, and then when you see the level 0, what all values I get. Okay, so the person A is assigned, the person A can be assigned the first job. So Riaz was asking a question that how are we assigning job to each person? So person A, I am just picking, and person A, what are the possibility I have? Person A can be picked up, given the job 1 or 2 or 3 or 4. These are the possibilities. Okay, Riaz. So A is a person name here. A is a person name. So A is assigned the first job, A is assigned the second job, A is assigned the third job, A is assigned the fourth job. Okay. So when that person A is assigned the first job, what is the lower bound value I'm getting? Okay, what is the lower bound value I'm getting is 17. And the lower bound value when I'm assigning the person A as the second job, I'm getting it as 10. So among all this, in the first level, I'm deciding the person A which job he must be assigned. So in level 1, I am deciding that the person A will be assigned the second job. From then I'm developing. I'm just neglecting this as neglecting these notes. That person A is assigned the first job, third job, or fourth job. I'm making it as unpromising note, not promising note. So only it is cross mark is there, and then I'm branching out to the next solution. Now I know that I'm going to assign person A as second job. Then in level 2, I have to decide person B should be assigned which job. So person B can be assigned which are the other jobs, Rias? 1, 3, 4 only. I cannot assign person B second job, right? So among 1, 3, 4, I feel that this lower bound, since it is 13, I feel that this is most optimal. Then I'm deciding the third person. I'm picking up the third person. Third person can, since the person A is assigned second job, person B is assigned the first job.